Hello, everybody. This is Dr. Amina Soayed. I'm going to talk today about a very important topic, which is the difference between atoms, elements, and compounds. Many students get confused about this difference. What is the difference between an atom and an element? What is the difference between an element and a compound? And on the other hand, what are molecules? As you see in this slide, there is a relationship between elements and molecules, some of the elements, of course, not all of them, and molecules. And there is a relation between molecules and compounds. But are all molecules elements? Are all elements molecules? Are all compounds molecules? Are all molecules compounds? That's what we are going to see today. Now, as you see in this slide, that matter is divided into pure substances and mixtures. And as you see here, that pure substances can be converted into mixtures, and mixtures can return back into pure substances just by a physical mean. And of course, this is another topic that we are going to talk about later. But today we are going to concentrate about pure substances. What are pure substances? As you see here, that pure substances are either elements or compounds. And elements, by chemical reactions, can be changed into compounds. But compounds cannot be changed back into the elements except by a chemical method, by doing a chemical reaction. But we can form compounds out of their elements also by chemical reactions. Now, today I want to see what is the difference between an element and a compound. As you see here, examples of elements are oxygen gas that we breathe. We have hydrogen gas, we have iron, we have sodium, we have helium, argon, and others, of course, as we're going to see now. And if we want to take examples of compounds, compounds like water that we drink, we have table salt, which is sodium chloride. We have ammonia. These are examples of compounds. And of course, we are going to see more about this. Now, today we are going to start with what are elements. We see that elements could be metals and could be non-metals. Metals like sodium, potassium, copper, and iron, all these are metals. And we have elements as non-metals, like, for example, helium, neon, argon, carbon. We have other non-metals like hydrogen, nitrogen, oxygen, chlorine, and bromine. And this means that for elements, elements are divided into we'll see that elements can be divided into two categories. Elements could either be monoatomic, elements could either be monoatomic, or they could be diatomic. And of course, we are going to see that there are others, but the main group of elements are the monoatomic elements and the diatomic elements. Now, what do we mean by monoatomic? Monoatomic means that the element consists of only one atom. But diatomic means that the element consists of two atoms. But here we must say two similar or two identical atoms. Either we say two similar or we say two identical atoms. So examples of monoatomic elements are all metals like sodium, like potassium, like copper, like iron, So all metals are monoatomic, and we have non-metals, the non-metals like carbon, and like all the inert gases, like helium, like neon, like argon, and so on, krypton, xenon, all these are monoatomic. What do we mean by monoatomic? As you see here, monoatomic means it consists of only one atom. So here you will see that sodium element consists of only one atom of sodium. Potassium consists of only one atom of potassium. Iron consists of only one atom of iron. Helium, carbon, neon, all these, as you see, consists of only one atom. That's why we call them monoatomic. But in diatomic elements, they consist of two, and we have to put here more than one line about similar or identical atoms. Like, for example, what? Like if we say oxygen, when we say hydrogen, when we say nitrogen, you will see that in all these elements, every two similar atoms are bonded together chemically. They are bonded together chemically by a chemical bond, so that oxygen that we breathe in does not consist of only one oxygen atom, like in these monoatomic elements. No, it consists of two oxygen atoms that are bonded together chemically to form the oxygen diatomic element. For hydrogen, it's the same. Every two hydrogen atoms are bonded together chemically to form the hydrogen gas. Hydrogen gas consists of two similar hydrogen atoms bonded together chemically to form the diatomic element. We cannot say that hydrogen element consists of only one hydrogen atom. It consists of two hydrogen atoms that are bonded together chemically. For nitrogen, it's the same. It consists of two nitrogen atoms bonded together chemically. Of course, we have other examples like all the halogens, chlorine, bromine, iodine, and so on. All these consists of a diatomic element, because chlorine element consists of two atoms of chlorine atoms bonded together chemically. Of course, bromine the same, fluorine, iodine, all these are diatomic elements. And as we said, we have two other elements that are exceptions of the monoatomic and the diatomic. We have phosphorus, for instance. Phosphorus as an element consists of four phosphorus atoms that are bonded together chemically to form the element phosphorus. Element phosphorus that we know consists of four phosphorus atoms. They must be the four together to form the element phosphorus. We don't have only one phosphorus atom alone. No, every four phosphorus atoms are bonded together chemically to form the phosphorus element. And the other exception is the sulfur. The sulfur consists of 8 sulfur atoms bonded together, as we are going to study in our course, that 8 sulfur atoms are bonded together chemically to form the element sulfur. So for elements, we have a monoatomic element and we have a diatomic element. Monoatomic means that it consists of only one atom, and diatomic means that it consists of two or more atoms, like here. Of course, diatomic means that it has two atoms bonded together chemically. But as we said, we have phosphorus and sulfur that are elements that consist of more of two similar atoms. As you see here, it must be similar atoms. Now, these are elements. And as we know that elements are the smallest particle of any substance that cannot be divided more. If it is divided, for example, if I have an oxygen and I divide it into oxygen atoms, yes, it can be. But in that case, it will lose all the properties of the element. The element is the smallest particle. The element is the smallest particle of any substance that cannot be divided more in order to attain the properties of this substance. If I divide the oxygen element into two oxygen atoms, then oxygen is not anymore oxygen that we breathe. It will be called oxygen atoms, but not an oxygen element, the oxygen molecule that we breathe in. So elements are the building blocks of any substance. Elements are the building blocks of any substance, okay? Now, so this is the elements. Now, what about compounds? What are compounds? Now, if we look at compounds, we'll see that compounds are substances. Compounds are substances that are formed by the chemical reaction between two different elements, between two or more, of course, two or more. Now here we have to say different elements compounds are substances that are formed by the chemical reaction between two or more different elements. Now here we have to say different because here they must be different. If they are similar, then we return back into elements. If they are similar, then we have elements. But if they are different, then we have compounds. Examples of compounds, if we talk about examples of compounds, like for example, water. As you see here, water is formed of two different elements. It's formed from hydrogen element and oxygen element. When hydrogen and oxygen are chemically bonded together, they form a chemical reaction together by the action of heat, they will form water. So water comes from two different elements. When they are bonded together chemically, then we get the compound water. If, for example, I have carbon dioxide, carbon dioxide consists of carbon element and oxygen element. So we have two different elements, carbon and oxygen, that reacted together chemically by a chemical reaction to form the carbon dioxide. So as you see, compounds come from two or more different elements. For example, as a more different element, if we take, for example, something called sodium carbonate. So sodium carbonate comes from the reaction between sodium element, carbon element, and oxygen element. We have three different elements that are bonded together chemically to give our compound sodium carbonate. It comes from two atoms or two atoms of sodium reacting with one atom of carbon together with three oxygen atoms coming from the oxygen element. So here we have three different elements that are bonded together chemically. A chemical reaction took place between these three elements, you see here we have three different elements that will form sodium carbonate by the reaction between sodium element, carbon element, and oxygen element. So there is a difference, a complete difference between a compound and an element. The element consists of two or more similar atoms, as you see even here in phosphorus and sulfur. Although we have 4 atoms of phosphorus, we have 8 atoms of sulfur, but all of them are similar. 4 similar phosphorus atoms, 8 similar sulfur atoms. So they must be similar in order to get an element. But if we have 2 or more different elements, then we get a compound. Okay, so there's a difference between an element and a compound. Okay, what is the difference between an atom and a molecule? If we come to an atom and a molecule, now what is an atom? Of course, an atom is the smallest, it is the smallest particle of an element. It is the smallest particle of an element. If I have an element, whether it is a monoatomic element or a diatomic element or a more than diatomic element, then the smallest particle in this element is the atom. For example, if I have sodium element, so sodium atom is the smallest particle of that element. If I have a chlorine element, then the smallest particle of this chlorine element is the chlorine atom. It's only one atom. It's the smallest particle in an element. But of course, chlorine atom differs completely from a chlorine molecule. It doesn't have any property of the chlorine element. The chlorine element has certain properties. It's a gas. It has a greenish color, a greenish yellow color. It's an oxidizing agent. But if we look at the chlorine atom, it doesn't have any of these properties. The properties are completely different. The chlorine atom doesn't represent a chlorine molecule. A chlorine molecule or a chlorine element has certain properties that are not found in a chlorine atom. So the atom is the smallest particle of an element. Now, what is a molecule? A molecule could either be a diatomic or more, a diatomic or a polyatomic element, and it could be a compound. So whenever we have two atoms, two or more atoms bonded together, whether they are present in an element or present in a compound, we can call it a molecule. For example, when we take this chlorine element that we talked about just from a moment, when we have a chlorine element, since we have two atoms bonded together, then we can call it a molecule. We call it an element. We call it an element, and at the same time, we can call it a molecule. If we have oxygen, for example, it's an element. O2 is an element. And at the same time, we can call it a molecule. Why? Because we have two or more atoms, whether they are similar, as in the case of an element, or different, as we are going to see here in a compound, we can call it a molecule. Since we have two or more atoms bonded together, we can call it a molecule. If we have, for example, hydrogen gas, it's a molecule. If I have sulfur element, it's a molecule. If I have phosphorus element, it's a molecule. So we call it an element, and at the same time, we call it a molecule. Also, compounds could be called molecules. If I have H2O, which is water, if I have carbon dioxide, or if I have, for example, sodium chloride, this is sodium chloride. Since all these substances, two or more atoms are bonded together, then we can call them also a molecule. They are called compounds. These are compounds, but at the same time, they can be called a molecule. So the molecule is either an element or a compound that consists of two or more different, either similar or different atoms. It doesn't matter. Two or more atoms bonded together will form a molecule. A molecule could be an element or it could be a compound. But the atom consists of only one particle, which is the smallest particle of any element. This is the difference between an atom and a molecule. And of course, as we mentioned before, the difference between an element which consists of two or more similar atoms and a compound which consists of two or more different elements. So a molecule could be an element and a molecule could also be a compound. Okay, these are the differences between, as we have seen here, an element which consists of either a monoatomic element or a diatomic element, or a compound which consists of two or more different elements, and the difference between an atom and a molecule. Okay, so when we come back to the definition of an atom or an element, so we'll see that atoms are found in any matter. Any matter must consist of atoms, and atoms are very, very small, and it is the smallest particle in an element or in a compound and has no electrical charge. This is an atom. An element is a substance that consists of only one type of atoms and cannot be broken into simpler substance. Even if we have a diatomic element, if it is broken into atoms, then it will be no longer this element. It will be an atom. It will not be an element. The element must represent whatever we are talking about. Of course, the atoms of a particular element are all identical to each other, and they cannot be changed chemically into any different element. But a compound is a substance that contains of atoms of at least two, we have to say here, two different elements chemically combined together. As an example, if we take magnesium oxide as an example, it consists of magnesium atoms and oxygen atoms chemically bonded together. Of course, we have other examples as we have seen before. As other examples, we have hydrogen. Now, what is a hydrogen? Is it an element or is it a compound? Since hydrogen consists of two atoms of the same type, they are similar. Both of them are hydrogen atoms to form the hydrogen molecule or element. So hydrogen is an element. But if we look at sodium chloride, it consists of sodium atom chemically bonded to a chlorine atom. So in this case, sodium chloride will be a compound because we have here two different elements bonded together. Carbon consists of only one atom of carbon, and so it's an element. But carbon dioxide consists of two different elements, which are carbon atom or carbon element and oxygen element combined together chemically. So they will form the carbon dioxide, which means that it's a compound. Now, if we look at atoms, we will see that in an atom, the atoms, we draw them as a spherical substance, and we will find inside any atom, we will find a very small part, which we call the nucleus. The nucleus is very small, but inside the nucleus, we have two different particles. We have particles which we call protons, which are in red color, and we have other particles that we call the neutrons. Protons and neutrons are found inside the nucleus. That's why we call them together, we call protons and neutrons together, we call them nucleons. Nucleons means that they are present inside the nucleus. And outside the nucleus, we have what we call the energy shells. We call these around the nucleus, we call them energy shells. And energy shells are not definite path routes at which they are present, like our roads, for example, no. But they are only imaginary paths at which electrons are rotating around the nucleus. We call them energy shells. And we will see that electrons rotate around the nucleus in these energy shells. There is no path route that is drawn like this. But when electrons rotate around the nucleus in this way, so that's why we call the path at which electrons rotate around the nucleus, we call it energy shell. And as you see, we have in any atom, we have different energy shells. As more and more electrons are present, because in energy shells, electrons rotate around the nucleus. And we will see that as more electrons are present in an atom, then we have more and more of these energy shells. We have either one energy shell in an atom of hydrogen or an atom of helium. As example, we have 2 energy shells in, for example, beryllium. We have 3 shells in 3, 4, or 5, or whatever shells in other atoms. The more the number of electrons, the more we will have of energy shells. And we will see that an atom should be electrically neutral. You will see now that protons have charge. As you see here, there is a positive charge written above each proton. And for electrons, they are negatively charged. And the atom as a whole should be neutral. It should be electrically neutral. And this means that as much as positive protons present in the nucleus, there must be the same number of electrons rotating around the nucleus in the energy shells, so as the atom will be electrically neutral. The positive charge cancel with the negative charge on these electrons. We call these 3 particles, protons, neutrons, and electrons together, we call them subatomic particles. The 3 of them together are called subatomic particles, but protons and neutrons only are called nucleons. As you see here in this table, you will see that these are the properties of particles, the subatomic particles in an atom. We will see that the proton has a symbol of P, neutron has a symbol of N, and electron has the symbol of E. And these are what we call the relative atomic mass. These are not the masses of these particles, but these are relative atomic masses, relative masses of these particles, the relative masses relative to each other, because protons, neutrons, and electrons have very, very, very small masses. So instead of writing their masses in grams, we will write relative masses in what we call atomic mass unit. This unit is called the atomic mass unit. It's a very, very small unit because these particles are very, very small. That's why we have certain units that we call atomic mass unit. They are very, very small. And these atomic masses, we do not write them, but we write relative masses. That the proton and neutron, each one of these particles has a relative mass of 1. Both particles are nearly the same in mass, so we say that they have a relative mass of 1. But for the electron, it's much more smaller than in mass than protons and neutrons. So we say that its relative mass relative to the masses of proton and neutron is 1/2000, or exactly it's 1/1845 atomic mass unit relative to the mass of neutrons and protons. And this means that the mass of the neutron can be neglected with respect to the masses of protons and neutrons because it's very, very small relative to the mass of protons and neutrons. For the charge, the proton has a positive charge. Also, this is a relative charge relative to each other, that the charge of a proton is positively charged. The charge of a neutral is 0. It doesn't have any charge. And the charge of an electron is negatively charged. And as we said, for an atom, it should be electrically neutral. And that's why in a neutral atom, the number of protons and the number of electrons are equal, so that the positive charge cancels with the negative charge of the electrons. And so the atom as a whole is electrically neutral. Now we come to what we call the naming of chemical compounds. How do we name chemical compounds? Before starting to know how to name a chemical compound, we have to know how to pronounce or how to name the positive ions and the negative ions that will form the chemical compounds. We know that chemical compounds consist of positive ions and negative ions that are bonded together chemically to form the chemical compound. When I say, for example, sodium chloride, which is the easiest compound that we always mention, sodium chloride it consists of sodium and chloride. As we are going to study afterwards in our course, we will see that the sodium chloride ionic compound is formed from sodium ions bonded together with, chemically, of course, with the chloride ion. So always a chemical compound, which we call them ionic compounds. This is the naming of ionic compounds, of course. An ionic compound always consists of a positive ion, which is chemically bonded to a negative ion. So here we say sodium chloride. So we have to know the names of each of the positive and negative ions in order to know how to write the name of an ionic chemical compound. So here, this is called sodium ion, sodium ion. This is called potassium ion. Of course, you have to know the names of these ions. At the beginning, if you look in the periodic table, as you've seen the periodic table before, under every element, the symbol of each element is written its name. But of course, for the negative ions, not all of them have their names, as we are going to see why. So if you look at sodium, this is called sodium ion. Potassium, this is called K positive, means potassium ion. Li positive means lithium ion. Mg plus 2, magnesium ion. Of course, during our study, we will know why sodium forms a positive ion, potassium and lithium, while magnesium forms a plus 2 ion, aluminium plus 3. This is going to be introduced into our course, inshallah. But these are the names of the positive ions. It's the name of the metal, but above it is written the charge of it. Some of the ions will have only positive 1 charge, others will have plus 2, thirds will have plus 3. And we just write the name of the metal, and beside it we write, or above it, we write the positive charge of it. For the negative ions, we have 2 types of negative ions. We have negative ions that are formed from the element itself, like, for example, chloride, we say Cl negative. So it consists of only 1 atom in the form of an ion. Or here, oxide, we have element oxygen, but in the form of an ion. We call this chloride, Cl minus, we call it chloride. And we have oxide. We have, for example, if I write Br minus, then I call it bromide. If we have, for example, nitrogen minus 3, we call it nitride. As we said here, oxide, O2 negative oxide. We have sulfide, for example. So as you see here, whenever the negative ion is an only 1 atom in the form of an ion, of course, we will see that an ion is either formed, a positive ion is formed when an atom loses an electron. We call it a positive ion. And if the atom gains electrons, we call it a negative ion. So here we have bromide, we have nitride. Always you will see that the ending of the name, sorry, the ending of the negative ion is "ide." When the negative ion is present as an atom, only 1 atom, always its name ends up with "ide." But for the positive ions, we mention the name as it is: sodium ion, potassium ion, lithium ion. But here we don't say bromine ion, we say bromide ion, nitride ion, oxide ion, sulfide ion. So we have "ide." But sometimes our negative ions, we call them a polyatomic ion. We call this a polyatomic ion. What do we mean by polyatomic? Polyatomic means that it consists of more than 1 atom that are bonded together. Like here, you will see that sulfur is bonded to O3, or sulfur is bonded to O4, or nitrogen is bonded to an oxygen in this one and that one. We have carbon bonded to an oxygen. We have oxygen bonded to a hydrogen. So we call these polyatomic ions. Polyatomic ions mean that it's an ion that is formed from 2 atoms that are bonded together. So on naming For example, nitrogen, we said that if nitrogen is present alone, we call it a nitride. But if nitrogen is present with an oxygen, we have two types of nitrogen bonded to an oxygen. Either we have nitrogen bonded to two oxygens to form an ion, or we have nitrogen bonded to three oxygens to form an ion. Now, when we have oxygen bonded to another nonmetal, then we have to say "ite." If we have more number of oxygen atoms bonded to an atom, we have to say 8. For example, this is called nitrite, and this is called nitrate. So you see here, when nitrogen was alone, we said nitride, IDE. But when nitrogen is bonded to a small amount of oxygen, of course, this small amount of oxygen depends upon the other ion that we are relating it to, because here we have NO2 and here we have NO3. Of course, the number 3 is greater than the number 2. So here we are going to call this polyatomic ion, we are going to call it nitrite, ITE. But here we are going to call it nitrate, ATE, because we have more number of oxygen atoms. The same here. If I look at sulfur here, we said sulfide when it was present alone. But here, when sulfur was bonded to 3 oxygen atoms, we call it sulfite, ITE. When sulfur is bonded to 4 oxygen atoms, we call it sulfate, ATE. You see here the number differed. In nitrogen, the nitrite was NO2 and the nitrate was NO3. But here the sulfite was SO3, 3 oxygens like here, 3, and the 8 was for the SO4. So it doesn't depend. It does not mean that we have either 2 oxygens or 3 oxygens. No. It depends upon whether I have another polyatomic ion that has more number of oxygen atoms. So I call the one with the lower number of oxygen atoms, we call it sulfite. And the one with the more oxygen atoms, we call it 8, sulfate. Here the number of less number of oxygen atoms, we call it nitrite. And here we call it nitrate. Okay, this is, for example, called carbonate. We have 3 oxygen atoms and we call it carbonate. Now for this is oxygen bonded to a hydrogen, we call it hydroxide, IDE, hydroxide. Here oxygen is bonded to hydrogen in a negative ion, we call it hydroxide. It means that there is a hydrogen together with the oxygen, hydroxide. This is the only positive ion that we have as a polyatomic ion, and this is called an ammonium ion. This is the only positive ion that we are going to see during our course. This is the ammonium ion, the only positive polyatomic ion. But as you see here, we have a lot of negative ions. And of course, depending on these positive and negative ions, we are going to name the ionic compounds. For example, here, when it says, write the chemical formulae of the following, here it says magnesium chloride. So we are going to, for naming this compound, we are going to, at the beginning, to write the symbol for each atom present in the compound. So magnesium is Mg and chloride is Cl. So at the beginning, we are going to write the symbol of each ion. Magnesium, Mg, chloride is Cl, means that it comes from the chlorine atom. And then we are going to see the charge on each element, on each atom, or on each ion. Of course, as I told you, we are going to study this during our course, how to know the charge on each ion. We will see that magnesium has a valency of 2, or a charge of +2, and the chloride has a -1, but we do not mind the positive and negative charge. And then we are going to flip the numbers for each ion with the other. And in that way, we are going to write magnesium chloride MgCl2. The magnesium has a +2 charge. We are going to see how do we get this charge. And chloride has a -1 charge. We don't mind the positive and the negative charge. We are only concerned about the numbers. And so we flip the numbers together. The 1 goes to the magnesium and we don't write it. And the 2 goes to the chloride and we write it. Now, for sodium nitrate, we start by writing the symbol of each ion. So the sodium is Na, and as we have seen in the previous table, nitrate is NO3, and we have seen that the nitrate has a -1 charge, and sodium has a +1 charge. So the 1 cancels with the 1, and the symbol of sodium, or the chemical formula of sodium nitrate, will be NaNO3. Okay. For aluminium sulfate, we have aluminium has this symbol. Of course, we know the symbols from the periodic table. And sulfate, SO4, as we have seen in the previous table. Sulfate has a -2 charge, and aluminium has a +3 charge. And we said that we do not mind the negative and the positive. We only cross the numbers together, and we get the chemical formula of aluminium sulfate, Al2SO4 3. Here, because the sulfate is a polyatomic ion, so when we want to put any number below it, we have to put it between brackets and write the number to show that this number is for the whole polyatomic ion. If we write it only below here, maybe we're going to be confused whether this 3 is for the oxygen only or for all. So we don't do that. We put a bracket around the SO4, and we write here 3, and here we write 2. Okay. So of course, we are going to practice more and more during our course about what is an ion, about how to write chemical symbols, and how to write chemical formulae for ionic and for covalent compounds during our course, inshallah. Okay, thank you so much, and see you in another video. Thank you.